Hello. Welcome back to our channel. So today we are going to learn about Lewis dot structures, how to draw Lewis dot structures very easily because children will be confused regarding this Lewis dot structures, how to draw them. These are the very important topic in our chemical bonding chapter. So let us see Lewis dot structures, how to draw. So before that, let us understand what are valence electrons. Okay. Let us understand what is meant by valence electrons. So valence electrons means the last shell electrons are called as valence electrons. For any atom, there are shells present in the atom. The last shell, whatever electrons are present in the last shell, that is considered to be valence electrons. Let us take for sodium. Sodium atomic number is 11. The configuration of sodium is 1s2, 2s2, 2p6, 3s1. This number, whatever I am writing, 1 or this number what I'm writing, this will tell you the shell. That means sodium has got 3 orbits like this. Sodium has got 3 orbits. This is our first orbit. First orbit. In that there is a subshell called as S subshell. In that we have got 2 electrons. Okay. This is 1 electron and this is another electron. We have got 2 electrons. That is our 1s2 means. 1 suggests the orbit number, S suggests the subshell, and these 2 electrons are present in that subshell. Okay. Next, let us see this. Here also it is 2, here also 2. That means second orbit has got 2 subshells, S and P. In S subshells, 2 electrons are there. In P subshell, 6 electrons are there. So second orbit has got 2 subshells. One is S subshell and one is P subshell. So now what happens? This 2 electrons will be present here and the 6 electrons will be present here. 1, 2, 3, 4, 5, 6. 6 electrons will be present. So overall, how many electrons are present inside second orbit? That is total 8 electrons. In first orbit, we have got 2 electrons. The second orbit, we have got 8 electrons. In the third orbit, the third shell, we have got S subshell. In that, we have 1 electron. That means we have 1 electron in third orbit. Now, if you can tell which is the last shell, which is the last shell? The third shell is the last shell. In that, we have 1 electron. So valence electrons is equals to 1 for sodium, and this is how we calculate valence electrons. So whichever last shell, the highest number, like 3 is the highest number, that is the last shell. In that, how many ever electrons are there? They are called as valence electrons. Now let us write the configuration of any other thing. Like let us write configuration for nitrogen. Nitrogen is 1s2, 2s2, 2p3 because nitrogen's atomic number is 7. 1s2, 2s2, 2p3. So this and this is going to give you the information about the shell. That is, there are 2 shells, first shell and second shell. In first shell, we have got 2 electrons. In second shell, we have got total 5 electrons. Now, can you tell me how many valence electrons are there? Yes, you are correct. The valence electrons are 5 electrons. 5 electrons are present in nitrogen. I hope you understood the configuration and taking out valence electrons. So let us move quickly to I will not be wasting much time on valence electrons. Let us move quickly to understand how Lewis symbols will be written. So you should practice this configurations, writing configurations. In atomic structure, we will be writing electronic configurations. You have to practice from there how Aufbau's principle, Hund's rule of maximum multiplicity, Pauli's exclusion principle, they are all used to write the configurations. So after writing the configurations, you have to check whichever is the valence electrons, and you should be able to understand that these valence electrons will be participating in chemical bond according to Lewis. Okay. Now, let us write the configuration. Now, what Lewis says is, whenever any atom, whenever any atom contains 8 electrons in its valence shell. What did he say? Whenever any atom contains 8 electrons in its valence shell, that atom is stable. This is what he has said. So that atom is stable. Now, every other atom, whichever is present in our periodic table, he says, according to Lewis, he says that every atom tries to get the 8 electrons in its valence shell. Okay, this is how everyone will be attaining stability. Understood? Now, let us see an example. Like, for example, there is neon. Okay, let us write configuration for neon. Neon atomic number is 10, 1s2, 2s2, and 2p6. When I take the valence shell, that is second shell, in that I have got 2 plus 6, that is 8 electrons are present in the valence shell of neon. So neon is stable. Let us take fluorine. Fluorine atomic number is 9. 1s2, 2s2, 2p5. This is 2 plus 5, that is 7 valence electrons are there. So what fluorine will do is fluorine will try to accept an electron and it will try to become neon. Okay, it will try to become neon's configuration. Okay, so I hope you understood how these elements behave for bonding. Fluorine will be always trying to accept an electron and becoming F minus. Similarly, sodium. Sodium 1s2, 2s2, 2p6, 3s1. So it has to either gain 7 electrons or lose 1 electron. Which would be better for the energy level? That is, losing an electron is better. So sodium always try to lose electron. As it loses electron, sodium now will have the configuration of 1s2, 2s2, 2p6. That means it will have a configuration of neon. So sodium will always try to be n plus 1 state. That is, it will always try to lose an electron. I hope you understood the valence and the valence electrons and the octet configuration. That is valence electron. In the valence electron, if at all we have 8 electrons, that is called as which configuration? Octet configuration. So every other element in our periodic table will try to attain this octet configuration according to Lewis. I hope you understood. Now let us draw few Lewis symbols. So first, let us take hydrogen. The configuration is 1s1. The valence electrons are 1. Valence electrons are 1. So when valence electrons 1, you have to put hydrogen like this. You have to put a single dot. That's all. This is your Lewis dot structure for hydrogen atom. If I take carbon, the carbon configuration is 1s2, 2s2, 2p2. So this 2s2, 2p2, these are the valence electrons. So what we will do, we will put 4 dots over carbon. This is your Lewis symbol for carbon. If at all I write sulfur, sulfur configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So these 6 electrons are the valence electrons. So I am going to draw 6 dots for sulfur. Yes, I hope you understood how to draw valence electrons and how to draw Lewis dot symbols. Yes. Now let us move to our topics for the day. These are all like I have created a base for you if you don't understand. This is what is the base. So now we will go to the trick, that is how to draw any Lewis structure that has been given for us. Okay. So now let us see. That is the point of our video today. So drawing of Lewis structure. How to draw Lewis structure very easily. Drawing Lewis structure. Let us take carbon monoxide first. Let us take carbon monoxide. Now, whenever carbon monoxide is given, we have to understand that according to Lewis, carbon wants 8 electrons in its valence shell. Oxygen also wants 8 electrons in its valence shell. So first we have to write what are the total required electrons for this entire carbon monoxide to become stable. That is 8 for carbon, 8 for oxygen. So total 16 electrons, if they are there, this carbon monoxide would have been stable. I hope you understood now. So the total required electrons for carbon monoxide to be stable are how many? 16 electrons. Now, how many are the valence shells? Valence electrons. Yes. So total electrons are 16, but in reality 16 are not present. Then even then carbon monoxide is stable. How is it stable? That is what we are going to check now. Valence electrons for carbon, just now we have seen, that is 4. Valence electrons of carbon is 6. And there is no charge present. If at all there is any negative charge present, we have to add those number of electrons here. If at all there is any positive charge present, we have to subtract those many from here. I hope you understood. So from valence electrons, we have to subtract. If at all any positive charge is there, if at all any negative charge is there, you have to add those many electrons. Now, how many valence electrons are there? The valence electrons are 10 electrons. The 10 electrons. With that 10 electrons, it has to behave as if it is having 16 electrons. How can he do that? He has to share the electrons. How will I know how many electrons have been shared? The shared electrons, you will be understanding the shared electrons by subtracting this total electrons minus valence electrons. So you have to subtract total electrons from the valence electrons. You are going to get 16 minus 10, that is 6 electrons. The shared electrons are 6 electrons. The shared electron information is going to give you bonds. Number of bonds is equals to 6 by 2. That is 3 bonds are present between carbon and oxygen. This information, after you get this information, please draw the skeletal structure. That is, draw carbon and oxygen and draw 3 bonds. These 3 electrons, the red color ones, are from carbon, and the 3 yellow color ones, or let us take any other color, that is a light green color one. These 3 are from oxygen. So two electrons will make a bond. So if 6 electrons are shared, that means 3 bonds are formed. Okay, I hope you understood. Then we'll see how many are unshared. That means out of 10 electrons, 6 electrons were shared. How many will be unshared? 4 electrons will be unshared. These 4 electrons, you have to distribute them back to carbon and oxygen. First, we have to distribute to the peripheral atoms. Next, we have to distribute to the central atom. In this case, carbon is considered to be the central atom because its electronegativity is less. Oxygen is considered to be the peripheral atom. So we have to share these 4 electrons to oxygen first, such that its octet is finished. So how many electrons does oxygen have? 1, 2, 3. In sharing, it is also sharing the electrons of carbon. So 4, 5, 6. That means our oxygen requires how many? 2 more. So out of those 4 electrons, please give 2 electrons to oxygen. Then we are now left out with 2 more electrons. Give those 2 electrons to carbon. Now check whether carbon's octet is finished or not. Check 1, 2, 3, 4, 5, 6, 7, 8. The carbon's octet is finished. And also oxygen's octet is finished. If you want, you can check 1, 2, 3, 4, 5, 6, 7, 8. I hope you understood. This is how carbon monoxide's Lewis structure is drawn. Okay. I hope you understood. Next, let us see one more. Let us take one more. Let us take NO3 minus. Let us take NO3 minus. Now, first we have to write what are the total electrons that are required. The total electrons that are required are this nitrogen requires 8, oxygen also requires 8, but 3 oxygens are there. So 8 plus 8 into 3, that is 8 plus 24, which is how much? 32. Now, after writing this, let us write valence electrons. The reality, that is, nitrogen has got 5 electrons, nitrogen 5 electrons. Then each oxygen will be having 6 into 3. And there is a charge present. So that is plus. So 5, 6, 3 is 18, plus 1, 19. That is 19 plus 5 is 24 valence electrons are present. Okay. Now what we will do? Let us write the shared electrons. Shared electrons means from total electrons, please subtract the valence electrons. 32 minus 24, that is nothing but 8 electrons. So we are totally sharing 8 electrons. Bonds, how many bonds will be formed? 8 by 2, that is 4 bonds will be formed. So nitrogen, 1, 2, 3 bonds are with oxygen. And as is suggesting 4 bonds, make a double bond. Okay, I hope you understood now. We have to make a double bond. Then what we should see? Unshared electrons. We should see unshared electrons. Unshared electrons are valence shell electrons minus this 8. Valence is 24 minus 8. That is how much? That is 24 minus 8. That is 16. 16 means, let us check. We have to give them to oxygens. 1, 2, 3, 4. So in this, nitrogen is the central atom. Oxygen is the peripheral atom. First, we have to give to oxygen, then to nitrogen. So first, out of this 16, this oxygen requires 4. Yes, because already 4 are there in sharing. So it requires 4. So we have to draw 1, 2, 3, 4. So we have removed 4. That means still 12 are remaining. Those 12, this guy should require 6. So 12, from 12, 6 are gone, still 6 are remaining. Those 6 must be given to this. So total, this is entirely it's done. So now nothing is remaining. This is our NO3 minus structure for NO3 minus Lewis dot structure. Any doubt? Now I show you carbon dioxide structure. Next we'll draw carbon dioxide structure. Carbon dioxide structure. Carbon dioxide structure. In carbon dioxide structure, the total required electrons are 8 plus 2 into 8. That is how much? 8 plus 16, that is 24. Valence electrons for carbon is 4. And for oxygen, it is 6. 6 to is 12. 12 plus, it is 16. 12 plus 4, it is 16. The shared pair of electrons would be 24 minus 16, which is 8. Bonds would be 4. So first we have to write the skeletal structure carbon. Let's put one bond oxygen, one bond oxygen, but it says 4 bonds are there. So try to put double bonds. Okay. Now we have to calculate unshared electrons. Unshared electrons are 16 minus 8. That is how much? 16 minus 8 is 8. That means I have to give 1, 2, 3, 4 to this, 1, 2, 3, 4 to this. That's all. This is your carbon dioxide structure. I hope you understood. Next, we can draw. What structures can we draw? We can draw. Let us draw in history structure, ammonia structure. Okay. So ammonia, 8 electrons for nitrogen and 2 electrons for hydrogen, because hydrogen is a atom which for which the octet configuration is not present. It is duplet configuration that is required. Why? Because the nearest inert gas for hydrogen is helium. It wants to fulfill its duplet configuration. I hope you understood. So total electrons in nitrogen, that is 8 plus 2 into 3, that is 8 plus 6, that is 14 electrons. So total electrons that are required are 14. Valence electrons for nitrogen, they are 5. Hydrogen are 1. 1 into 3, that is 5 plus 2, that is 8. So how many are shared electrons? 14 minus 8. 14 minus 8 is 6. Then bonds would be 3. Let us draw the skeletal structure with 3 bonds. So we'll put 3 bonds and we'll put 3 hydrogen. So bonds, correctly it is done. Now let us see unshared. 8 minus 6, that is 2. Now I cannot give this 2 electrons to hydrogen. Why? Though hydrogens are peripheral atoms, we cannot give it to hydrogen. Why? Because its duplet is already finished. So you can see hydrogen wants duplet configuration. Hydrogen wants 2 electrons. So hydrogen already has 2 electrons. So you cannot give these unshared electrons to hydrogen. Then whom to give? Then we will give to nitrogen. So this is the structure of our ammonia. Okay. Next, we are going to let us draw the structure for SO4 minus 2. We are drawing Lewis dot structures for SO4 minus 2. When I draw Lewis dot structure for SO4 minus 2, the total electrons that are required for sulfur 8 and oxygen, it is 8 into 4, that is 32. So total electrons required for sulfate ion to become stable is 40 electrons. The valence electrons that are present are 6 plus 6 into 4 plus 2. Why did I add this plus 2? Because of this charge. So 6, 6 4 24, 30, 32. 32 are the valence electrons. Shared pair of electrons would be 40 minus 32, that is 8. Bonds would be, shared are 8. Bonds would be 4. So let us draw sulfate structure. 1, 2, 3, 4 bonds. And 4 oxygens will be coming like this. Okay. Now, what are the unshared? 32 minus 8. That would be 32. From 32, if you subtract 8, it would be 24. Now, each oxygen requires 6 electrons. Why? Because everyone has got 2 electrons in sharing. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6, 4 is 24. All the electrons have been given. Now, sulfur doesn't get any lone pair of electrons. This is the structure for
sulfate ion according to Lewis. Okay, I hope you understood this. Now, let us calculate the formal charge also. Okay, let us calculate the formal charge also. Whenever we are calculating formal charge, there is a formula for it. We are not going to go into formula. According to structure only, we are going to check how to see the formal charge over sulfur. Okay, check whatever electrons are there with sulfur. How many are there? Only this part. Don't see the sharing part, only that part. How many electrons are there? 1, 2, 3, 4. So 4 electrons are there with sulfur. Nature has given the valence electrons for sulfur were 6. If there were 6 electrons, sulfur would be neutral. But now it is having only 4 electrons. That means sulfur is having +2 charge. So the formal charge over sulfur is how much? It is +2 charge. I hope you got it. It is +2 charge. The formal charge on sulfur is +2. Then let us calculate the charge on this oxygen. Calculate the number of electrons 1, 2, 3, 4, 5, 6, and 7. Nature has given the valence electron 6. If there were 6 electrons, oxygen would have been neutral. But now there are 7 electrons. One extra electron is there. So the formal charge over oxygen is -1. So this is -1, this is -1, this is -1, this is -1, and this is +2. Now if I calculate the entire charge, -1, -1, -1, -1, +2. This and this gets cancelled. When you add these two, you are going to get -2. That charge we are writing over the ion. I hope you get it. In the same way, in NH3, let us check. Hydrogen, 1 electron, 1 electron, 1 electron. No issues. Nature also 1 electron, no issue, no charge. Ammonia, you can check 1, 2, 3, 4, 5. Nature also 5. So there is no charge on nitrogen, there is no charge on hydrogen in this case. Next, let us see in this carbon dioxide. Okay, whenever I write carbon dioxide, let us check what is the charge on oxygen. So 1, 2, 3, 4, 5, 6. Nature is 6. Nature is given 6 electrons. Here also 6, no charge. Carbon 1, 2, 3, 4. Nature also has given 4. Here also 4. There is no charge. In this, you can check. In this also, there will be no charge. So overall, there is no charge on carbon dioxide also. Next, let us see nitrate ion. If you check this, 1, 2, 3, 4, 5, 6. So there is no charge. If you check this, 1, 2, 3, 4, 5, 6, 7. There is -1 charge. If you check this, there is a -1 charge. If you check this one, 1, 2, 3, 4. So here it is +1 charge. So when I add all the charges, -1, -1, +1, this and this gets cancelled. -1 will be remaining. That will be written here. Okay. Next, we have got carbon monoxide. This is very important. In carbon monoxide, you can check oxygen has got how many electrons? 1, 2, 3, 4, 5 only. That means nature has given it 6 electrons, but oxygen has lost an electron. So this would be +1 charge. When you check carbon, carbon also has 1, 2, 3, 4, 5 electrons, but nature has given it only 4 electrons, 4 valence. But here it has got 5. So this will have -1. What is the overall charge then? -1 and +1. Both will be cancelled. It will be 0 formal charge. So this is a method to draw Lewis dot structure. Any Lewis dot structure you can draw with this method. Okay. So kindly, I want you to draw carbonate, okay, and water, and H3O plus, NH4 plus, and what else you can draw? It's okay, fine. These are enough. If you practice this, then if at all you have any doubt, kindly let me know. Okay. I hope you understood this. If you have any doubt, please comment below. Thank you.